This is your homework from the workbook, page 413 to 418, chapter 3.1. 413 is this problem here. Let me check if I'm right. Yep, and a review question. Okay. Let's see. I'll go over the 5 times. I'll go over the review question. Okay, remember, use the graph to write a rate of change, a rate that compares the change in elevation to the change in time at point D. Okay, so they want you to use point D right here. Basically, you can choose any points on this graph, okay, to compare, because it's all on the same line. You'll see your answers the same no matter which 2 points you choose. So let's say you choose point E, okay, these 2 points. So remember, as I mentioned in class, it's distance over time. Rate of change is distance over time. Okay. So let's look at point D. Distance over time. So the distance is 50. Distance is on the y coordinate, you see. So distance is y, time is your x, so over x. So your y over x, this is very important for later, that you understand distance is in the y coordinate. Time is always the independent on x. It's the change in y over the change in x. Very important you understand that, because the graph will change. This is distance over time, but later that's still distance over time. Distance over time, elevation. See, it changed to elevation over time. Same thing as distance over time, I guess. But distance over time. Yeah, these are all distance over time. Elevation. Same as distance. Cost. Look, cost over number of items. This has 2 graphs, but so now it's cost over number of items. So it's very important you understand it's whatever y is, the dependent variable over the independent variable. So distance over time, so y over x. I'm going to start saying y over x. Your y is 50 over your x, which is 5. 50 over 5. And your e coordinate, it is 120 over 12. So basically, this is distance in feet over times in minute, feet per minute. That's how we get our answer, feet per minute. Subtract 50, that's 70, negative over negative 7. 70 feet over 7 minutes, or 70 feet in 7 minutes. 2 negative is a positive, or 10 feet per minute. Or 10 feet every 1 minute. That's your answer. 2 negative is a positive. It's a positive graph because it's going up. Okay. Next one. Again. Use the graph to write a rate that compares the change in elevation to the change in time, point E. Well, they definitely want you to use point E this time. Okay, you can use point E is right here. Either you do point E to point F, or you can go back to point E to point D right here. Okay, it doesn't really matter. But they want you to start with point E. So E is distance over time. So in this case, elevation, even though you use the change in elevation, the reason why they use the word elevation is a mountain climber, how far they go up. They use the word elevation. E is 120 again, over a time of 12 minutes. And either F or D, let's say F, because we use D on the other one. You'll see that our answer is the same as the last problem, problem 4. Let's go F. Okay. Point F, just so you see that the rate of change on the same line is the same no matter what. Oh, sorry. Forgot to change. Okay, point F. F is distance 180 over time of 6. So distance over time, or the change in y, this is x, this is y, this is x. They call this, because this is our first point, they call that y1, y2. This is our second point, they call that, y1, x1, and y2, x2, y2, because it's the second point. Okay, second point, first elevation, and different. Okay, so that's what they call it. So I'm going to erase this so you're not confused. Just want you to hear this now, because it's really important later. Negative 60 over negative 6. Negative 60, these are feet. This is minute. So this is feet per 6. So they're going down. 2 negative is a positive. So it's good. They're going up 10 feet for every 1 minute, or just 10 feet per minute. Notice, same answer as here. The rate of change is always the same on the same line. Makes sense? The rate of change is the same. Okay, numbers. Okay, use point F. Use the graph to write a rate to compare the change in elevation in point F. Oh, they really want you to see that's the same. So basically you start with that point F. Remember, it's y over x, or in this case y is the distance over time. X is time, the independent. Time, distance over time. Very important. So the change in y in this case is 120. I need to change. 180, over the change in x, it's 18. And you can pick any point. Let's say you pick D. Be creative, pick D. This is F to D. D is 50 feet over 5 minutes. So we get 130 over 13, which is 10 over 1, 10 feet over 1 minute. Notice the rate of change is the same no matter what 2 points you choose. That's what they want you to see in this problem, is that the rate of change is the same no matter which 2 points you choose. on a graph. Just make sure you choose points that are on where they crossed right there so you can have nice round numbers. And you do not choose ever points like this in the middle where you are estimating your points. That is incorrect, okay? We'll face that later. Okay, let's do number 8. They did number 7 for you here. Number 8. Distance in meter, elevation in meters over times in seconds. Remember, this is y over x. Y over x. Very important that you remember that. Let's choose our first point. Anywhere you want, just as long. I'll choose 1 and 40. Oh, okay. I'll choose this one, watch. 0 and 45. We'll do that. 0 is our x, which is seconds. 0 seconds. And our y is 45 meters. Okay, I'm going to choose that's distance in meters over time minus my second point. Let's say I'll choose 3 and 30. So it's 30, y first, 30. This is our second point. Because this was our first point, we know that as x, y1, x1 minus y2. This is our second point, which is 3 and 30. So we label that y2, x2, which is minus 3. That's how they come up with the point with the slope formula, okay? So this is meters and in seconds. So 15 negative 3, if you subtract that, notice it's a negative 5. And the graph is going down because it's a negative slope or rate of change. You'll hear me say the word slope now, also with the rate of change. Remember, slope, rate of change, speed, how fast, all means the same. Okay, it's going down, so this person is going down 5 meters per second. Okay. Number 9, same thing. I think you guys can handle the rest on your own. I'll do one more. You pick any points you want. Okay, I'm going to pick, how about the very last, next to the last. That's my first point. So that is on a graph. 9 and 54. And I'll pick another point. We call this, because it's our first point, x1, y1. Okay. Our next point, let's say right here. Right here. Okay. That is 4 and 24. We call this x2, y2. So let's look at our first point. Remember, it's distance over time, so 54 over 9. So y1 over x1 is, and then the other one is y2 over x2. So our problem is 54 over 9. That's our first one. The second one is 24 over 4. So it's 30 over 5, 31. 30 is feet over 5 minutes. Therefore, our answer is 6 feet per minute. 6 feet every 1 minute. Okay? This is an important formula you'll learn later. Still distance, in this case it's distance over time. I think you can handle the rest of this without my help. Right? I hope so. Okay.